That turned out to be completely revolutionary because they immediately showed how millions of proteins can fold. It has accelerated development in biology by decades.
Welcome to the 5-Year Frontier podcast, a preview of the future through the eyes of the innovators shaping our world. Through short, insight-packed discussions, I seek to bring you a glimpse of what a key industry could look like 5 years out. I'm your host, Daniel Darling, a venture capitalist at Focal, where I spend my days with founders at the very start of their journey to transform an industry. The best have a distinct vision of what's to come, a guiding North Star they're building towards, and that's what I'm here to share with you. Today's episode is about the future of biomanufacturing. In it, we cover the emerging $4 trillion bioeconomy, nature's ability to manufacture products, AI's acceleration of scientific discovery, China's quest for biological supremacy, and rethinking sustainability. Our guide will be Edward Shenderovich, CEO of Synonym, a company that develops, finances, and helps build the infrastructure for biological manufacturing. Backed by top VC firms such as Andreessen Horowitz and Giant, Synonym is a pioneering force in helping develop the capability to grow materials and create products using biology as opposed to existing production techniques. A frontier area of materials science and production that promises to transform the world economy and progress sustainability. The World Economic Forum puts the value of the global bioeconomy to be over $4 trillion, and over 50 nations have already published bioeconomic strategies. Before founding Synonym, Edward was both an investor and an entrepreneur, founding commercial real estate company Notel, where he raised over $400 million and managed 200 locations across 4 continents. As an investor, he founded Kite Ventures as well as Essential Capital, which included Delivery Hero and Fiverr as their investments, both reaching IPO. Uniquely, Edward is also an accomplished poet, having published multiple books in his native Russian. Edward, nice to see you. Thanks for coming on.
Thank you for having me. It's such a pleasure.
Biomanufacturing, right? It isn't a term that we hear often in technology. It's a relatively new one to most people. Can you help us visualize what it means? And can you give a couple of examples of some products that are manufactured using biology?
Of course. Biomanufacturing is a pretty wide term. I guess just like manufacturing, it's a production of stuff. With biomanufacturing, it's a production of various substances using biology. Those substances can range from pharmaceutical products like insulin, which is a very widely used biomanufactured product, to new types of biomanufactured products like precision fermented egg proteins. We can also make various types of bioplastics and different bioresins. We can replace lots of different specialty chemicals with various bioproducts. Surfactants, or these surface-acting agents, which are used in paints and dyes so that paints and dyes don't crack. They reduce surface tension, or different emulsifiers, preservatives. All of these can be manufactured using biology. There are lots of agricultural products, biofertilizers, products that induce nitrogen fixation and reduce the need for fertilizer, or different types of biopesticides, which ultimately would be better for nature and better for us as consumers of these natural products.
So really wide gamut across many different sectors. And is there a common link around why someone would use biology to manufacture versus the existing process? Is it around sustainability, performance, cost?
Biology is a phenomenal tool of creation. Ultimately, we are products of biology. With biomanufacturing, we're trying to take the tools that nature has given us and turn them into powerful instruments for making stuff that we need. Over the last 150 years, we've used chemistry in this way. Once we started industrializing oil, we've built a phenomenally massive petrochemicals complex with oil extraction and refineries and transportation, and we use it for energy and materials. In the same way that there's an energy transition, we're moving away from using oil. In parallel to it, there's a materials transition. We're moving away from using various types of petrochemical products and petroplastics. So we're sort of separating oil, on which the chemical industry has been built, into an industry of energy, which deals with electrons, and an industry of biology, or the bioeconomy, which deals with materials and substances. So the beauty of biomanufacturing versus traditional manufacturing is that on the same infrastructure, you can use various types of inputs process them within that infrastructure, and then push out various different types of outputs. So it's an extremely versatile platform, which we're just starting to harness.
And all of this fits into what you call the bioeconomy. And Synonym is really playing the role of providing a lot of the infrastructure for this bioeconomy. So where does that kind of start and stop when you start to frame infrastructure and the bioeconomy?
Biomanufacturing has been used in pharmaceuticals for decades. It's a proven technology. There was a company called Genentech, which discovered a way to make insulin using recombinant DNA. Over the last 40 years, we moved away from animal-based production of insulin to precision fermented, what is called synthetic, but it's really very natural. That's a huge industry. It's the way we produce vaccines and ultimately Ozempic, our miracle weight loss drug, and all the other related pharma products. Pharma is a massive industry. It's also heavily regulated and has very long cycles. So as Synonym, we decided to focus on the rest of the bioeconomy, on food products and bioindustrials, which are not regulated, will require massive amounts of infrastructure, and it's an industry that still needs to be built. So we started with this idea, which I think seems pretty simple and pretty straightforward, that if the bioeconomy is going to be a massive multi-trillion-dollar market, or will have a multi-trillion-dollar impact on the economy, on the GDP, then this economy will need massive amounts of infrastructure. There will be trillions of dollars funneled into infrastructure. That capital will only come from professional investors, from infra funds and private equity, and ultimately public markets. And this is what happened in many other markets. It's what happened in data centers and then in renewable energy. It's also to an extent happening in chip manufacturing, where you have companies like Brookfield partnering with Intel to build multi-billion-dollar facilities. It's the idea of separating real estate ownership from usage. There are not many companies that buy their own offices. So why do companies need to buy their own manufacturing facilities? In the past, it was that these manufacturing facilities were specific for the products that these companies are manufacturing. But if you have a limitless number of inputs and limitless number of outputs on the same infrastructure, that infrastructure becomes an asset class. It's something that's tradable, where investors can buy shares in those facilities and sit on dividends. And we've seen many asset classes develop in this way. Let's think about biomanufacturing infrastructure as an emerging asset class. This is something that will happen in 20 years. Let's play that back and see what needs to be done now to effectuate that within the next decade. And we started the company about 2.5 years ago. We used that concept and also the idea of Amazon's cloud as an inspiration. What would a biomanufacturing cloud look like? So we started developing the digital layer for accessing infrastructure and planning how to build that infrastructure at the same time.
Very smart. And where are we in the US at the moment in terms of how much infrastructure is in place right now versus how much would need to be in place to be able to start to get some meaningful scale and products on the market?
There's a lot of infrastructure that has already been built over the last 40, 50 years. That stock is pretty old. It's not optimal for future production of biomaterials for a variety of reasons. Also, there's not enough of it. In total, there's about 50, 60 million liters of fermentation capacity in the world. In order for us to get to even move the needle in terms of sustainability in production of bioproducts, we need this to expand 100-fold, maybe over the next decade. That's a really daunting task. Who is going to build it? Where do we get the labor to do it? We're just taking it step by step. Synonym will not build 100 times more infrastructure than currently there, but maybe we'll build tens of millions, ultimately hundreds of millions of liters.
It sounds like it is a bit of a process of going from a centralized type of industry into more distributed. And I saw you got a Department of Defense contract recently that says you're building a distributed bioindustrial manufacturing program. So maybe you can unpack that a little bit further and say why it's so critical to US supply chain.
The Department of Defense has a thesis around biomanufacturing, and they've really been at the forefront of technology usage for decades. For them, it's important for a number of biomaterials that they want to use in their supply chains to be produced in the US and for these supply chains to be what they call uncompromised. And their priorities are fuel, fitness, fabrication, firepower, and food. There are some very interesting applications that the DoD has in mind. One in particular, it's online, you can Google it. It's for production of hackfish slime. It's an RFP that the Navy put out for production of this special material. So there's this fish, hackfish, some pocket within it. Within that pocket is the biological substance. And when it gets ripped and that substance is exposed to air or water, that substance expands 10,000 times in a matter of milliseconds. And that creates this slime that envelops the fish. The Navy wants to use it as a ballistics deterrent. Imagine you're underwater, someone is shooting at you, or maybe sending a projectile towards a submarine, and the submarine feels that, and that slime expands and creates a shield. And the projectile sticks in that shield. It will be more structured. Maybe the material itself will be more dense. The key thing is that we can't just milk hackfish. We can't pull that out of those sacks. We will need massive amounts of it. And that product can be produced in large steel tanks called bioreactors. And that's just one application. There are lots of other potential applications of biology. Just taking inspiration from the real world, from various organisms that nature has given us and various enzymes and proteins that are available that we're discovering all the time and applying them to solving problems that we have.
So elegant. And I bet there's endless amount of learnings from nature. Has there been a recent unlock in terms of the technology that has come together or progressed to allow for this new biomanufacturing and bioeconomy to take place, whether on the software side, on the material science side? Has there been some sort of convergence that points to this is the right time for this industry to start to take shape?
AI and massive big data processing is helping us make sense of biology and will be an amazing unlock for the industry. One of the things that happened over the last several years has been the solution to the protein folding problem. We didn't know, we knew the structure of the proteins, but we didn't really know how they fold. This was a problem that generally was the team from DeepMind, this UK-based artificial intelligence, they created a platform called AlphaFold to solve the protein folding problem. That turned out to be completely revolutionary. They immediately showed how millions of proteins can fold. It has accelerated development in biology, maybe by decades. There will be other AI applications. And, you can also ask GPT to write certain DNA. Those DNA strains can go into those microorganisms and help us modify those life forms. It's super exciting, super scary, but it will happen. We will create foundational models that will allow us to create new types of organisms or modify existing ones faster.
And if you're talking about AI increasingly helping with the design process, are we going to be increasingly moving towards an AI-led design process for the types of products and the types of biological products that you're developing?
I think certainly AI assisted. There are some people talking about autonomous science or automated science, where AI will also determine what scientific problems need to be solved. We're not there yet, but just like we're thinking about AI writing text and, maybe routing traffic, we will get AI to help us write DNA. And we'll get AI to help us set problems that we want to solve. And it will take some time, but we're far on the way. We're doing even better than Ray Kurzweil predicted in his wildest predictions.
Fast forwarding 5 years, we're at this interesting trajectory. And I know 5 years isn't a long time. In your world, you still have to build a lot of infrastructure, you still have to get a lot of investment, etc. But as this starts to interlock together, what are the types of industries that you think will be to be transformed first from there that will have the biggest impact on the world and really awaken everyone to the promise of the bioeconomy and biomanufacturing?
I think there's a huge promise in replacing some of the commodities or commodity-like products that we now use, whether it's at making certain milk proteins be precision fermented or egg proteins, taking parts of animal agriculture off the table, especially the parts that we don't see. Like, for example, 36%, I think, of all eggs go into baking or cosmetics immediately. We don't even see them as consumers don't see them as eggs. These industries will be transformed. There's a question of price parity, making sure that these products are sold at the same price, and I think there will be a step change. So we'll first focus on products which have higher margins, where we can build infrastructure, test these things out. There may be more of a margin for error, and then we'll ultimately move towards commodity applications. And these products can be wellness for humans, but can also be wellness for agriculture, like biofertilizers and biopesticides, which don't have these bioproducts, which don't have chemical alternatives. Could be certain products that are used for better types of plastics processing.
What's happening in the energy industry? What are some of the innovations that you're seeing with biomanufacturing and the intersection of new forms of energy or energy production?
Well, there's a huge market of sustainable aviation fuel, which is ultimately a byproduct. We started producing ethanol at scale in early 2000s. There's a large ethanol industry that has been built in the US that's turning corn into ethanol. The next stage of that is moving away from oil-based aviation fuel to sustainable aviation fuel, which is made from bioproducts. That will be a huge change. All the airline companies have made multi-billion-dollar commitments to moving to sustainable aviation fuel. And there are some companies that are working on bringing this to the market. And once again, we still need to build a lot of infrastructure.
And so aside from the consumer demand, the investment dollars into that, what are the other kind of things that would really unlock the progress and set you on a new trajectory for this industry?
It's consumer demand and also corporate demand. So large companies need to feel that it's important for them to incorporate bioproducts into their supply chains. There needs to be consumer pull to do that, or some regulatory change to incentivize them to adopt bioproducts and incorporate them into their supply chains. So the large companies will be the big unlock. There's also a need to build infrastructure, and that will require infrastructure funds to lean in, and they will not do it until there's corporate demand. There's definitely the government support is needed, and governments are now leaning in. And all of that is really secondary to the fact that we need the right technologies. And AI is a big unlock. So we are at this amazing moment in time when these things are coming together. There are companies making commitments to adopt bioproducts. The government is leaning in with this, with DoD and the DIPSI program. DOE has just did one of their first biomanufacturing deals with Sologen, providing them with a $200 million loan guarantee. There are lots of technological advances. So I'm very excited about this moment in time and whatever the next 5 years will bring.
I was reading as part of the research that there's over 50 nations that have committed to some sort of, biomanufacturing process. And it sounds to me that a lot of the actual biomanufacturing is concentrated at the moment in Europe versus the United States. Are there nations or ecosystems around the world that are pointing what it will be like when this starts to take shape and a little bit further ahead of the curve that we can look at?
You're right that Europe has terrific biomanufacturing talent. Europeans so far have built more infrastructure. One of the best, really inspiring pilot demo facilities is outside of Ghent. It's called BBEPP. It's really seen as the gold standard of what a small-scale biomanufacturing facility should be like. But I think U.S. is very quickly catching up. We also know that China has made biomanufacturing, it's one of its 5-year plan priorities, and they have already built up a lot of infrastructure. Over the years, China has taken a number of U.S. facilities offline just by undercutting them on price and on bioproducts. That is certainly a threat. Both U.S. and Europe need to take that very seriously. At the same time, there's a lot that's happening in India on the biomanufacturing side. It seems to me that just like China made its economy or built its economy around traditional manufacturing. India is trying to do the same thing with biomanufacturing, looking at building up capacity and leveraging its talent in that way. We also know that other countries have made biomanufacturing as priorities. Saudis have issued a biomanufacturing strategy. There's one in UAE. There's a very strong biomanufacturing strategy and really inspirational in some way in Singapore. It's not something that's isolated in the US or specific to Europe. It is happening everywhere in the world. I think that many countries have an opportunity to win. Many regions have an opportunity to win.
Well, speaking of winning, it sounds like a really big prize. It feels like a lot of the products that we could produce in the world could be done using biology.
Yeah, I think that biology can influence the production of everything. Just like let's replace the word plastics with bioproducts. We can't imagine our lives without plastics. We're wearing these headphones and you're speaking to microphone and our computer and probably the chair that you sit on and the desk you have, they all have plastic components. And everything that's around you is ultimately in some way a product of chemistry. Well, imagine everything around you being a product of biology. It's not only more sustainable, but they're completely different, better products. And in many cases, we don't know what these products will feel like. We can imagine some things, like imagine self-healing paints or clothes that don't wear out because they're made from spider silk. There's a lot of chemistry that we're pumping into the soil to make our trees bloom and produce fruit. Imagine how much better these products would be if we're using biological products which are more suited to that environment. I think that the future of the bioeconomy and biomanufacturing is exceptionally bright. And something that I overheard in Washington recently is that the UK won the Industrial Revolution. The US won the digital revolution, and China wants to win the bio-revolution. Well, the US definitely doesn't want China to win the bio-revolution, and neither does Europe. We want to make sure that we continue pushing towards this GPT moment in biology and biomanufacturing, and make sure that it's not a Sputnik-like moment where we wake up and those other guys have launched something into space.
Yeah, you paint such a big picture and big vision for the transition, and it feels really real. It feels like there's a really pivotal moment in time that's converging at the moment and over the next couple of years. So thanks so much for sharing that with us today and to paint the vision for us. Congrats on everything that you're doing at Synonym, and really excited to watch it unfold.
Thank you for having me. It's been a pleasure to chat, and I hope we can revisit this and do it again in 5 years and see what has actually happened.
Perfect. I love that. All right. Thanks, Edward.
Thank you.
What a fun and fascinating topic to discuss, an area of science, technology, and manufacturing that is moving from the world of pharmaceuticals into the wider economy. It's clear that we'll be hearing a lot more about biological manufactured inputs, substitutes, and even entire products as the infrastructure begins to come online. Unlocks like AI's ability to help scientists understand, design, and manipulate organisms are accelerants of change, which, as Edward points out, are advancing progress by the decades. To follow him, head over to his profile on X at eShender, ESHENDER. I hope you enjoyed today's episode, and please subscribe to the podcast to listen to more coming down the pipe. Until next time, thanks for listening. Have a great rest of your day.